How are you all doing? A warm welcome to IGBits. All subscribers, listeners, watchers, and whoever made it possible to today join in our session. For everyone, IGBits welcoming you for happy learning. We shall continue partial fractions rule number 4 in today's class. Without further delay, let's get started. Request to all viewers and listeners, if you have not subscribed the channel, please subscribe our YouTube channel. We have started uploading all learning videos on timely basis. Okay, a great help and great helping hand to extend who are actually in need would be a great the support to the system, right? So we are trying to put our efforts to build the knowledge base, and then I want you all help us to share the knowledge sharing sessions to the your friend circles. Extend your support and be a helping hand to build a great knowledge competency teams. Thank you all for your wonderful support so far, whatever you did it, but I would like and wish it to be continue further. Thank you all. So rule number 4 is similar to rule number 3 except one additional condition. In rule number 3 what we studied is irreducible factors, but occurrence is only one. In rule number 4 what we are talking about repeated irreducible factors. Okay, if the degree of irreducible factor is greater than 1, then how you are going to solve this problem? That's what partial fraction rule number 4 tells us. Let f of x by g of x be the proper fraction, and then n is greater than 1, n is belongs to natural number, is the largest component, let's say ax square plus bx plus c whole power n is what given in g of x in the denominator. Then corresponding to each factor, right, each irreducible factor for which a partial fraction exists in the form of ax plus b by same. So a1x plus b1 by ax square plus bx plus c plus a2x plus b2 divided by ax square plus bx plus c whole square, and so on. You see this one rule number 2, right? Repeated factors rule number 2 and then irreducible factor rule number 3 put together to arrive a rule number 4. That's simple. Okay, and then a1 b1 a2 b2 an bn, all these terms are constants, non-zero values or 0, depends upon your findings, but to be determined, and then plug in back into this expression to get a partial fraction for the given proper fraction. That's an idea. Okay, so let's give a small example which help you to identify rule number 4 how you're going to apply. Let me write down this one. Here I am supposed to be irreducible. Okay, x given proper fraction is x plus 1 divided by, so irreducible factor that we studied also, right, x square plus x plus 1, and that this has to be repeatable, means like you put x square, is it? Then I can say straight away this is rule number 4, because this is x square power 2, like x to the power 4, right? Numerator degree is lesser than the denominator degree, and hence this is a proper fraction. Now this is irreducible factor, this is irreducible. Okay, then we have a square, so it's a repeated, irreducible repeated in g of x for a given proper fraction. Then obviously you have to use rule number 4. What it talks about this one. How do you express this? Let's say ax plus b divided by x square plus x plus 1. This is first iteration. Go to the next one, maybe cx plus d divided by x square plus x plus 1 whole square, right? Because this is n is equal to, so I have two terms. This is how you can solve. Let's not confuse, because I used here like a1 x plus b1, a2 x plus b2. You can still use the same thing, a1 x plus b1, a2 x plus b2, then you can find out. So to make it our understanding easy, I just use like ax plus b and cx plus d. Otherwise you could also use something like this, a1x plus b1 and then a2x plus b2, so over x square plus x plus 1 here, and then x square plus x plus 1 whole square here. You still can use it, both are same. Alright. Alright, let's look at this problem. Resolve x square plus 1 by x square plus x plus 1 whole square into partial fractions. Good. So given equation is like a proper fraction because degree of numerator is lesser than denominator, because this is not x square whole square x to the power 4, right? Proper fraction. So now resolving proper fraction into partial fraction is possible, but the question is which rule that I have to apply. We just seen that, right? X square plus x plus 1 is irreducible factors. We cannot right away find out a factors for this, because discriminant, if you see b square minus 4ac gives like a negative value, is the imaginary. That you can refer previous slides if you have a question. Okay, you can skip the, you can move backward to find out, you know, how you are actually describing this value. So in rule number 3 you will get it. So this is irreducible factor, and then you are also talking about a repeating because you have a square. So definitely we have to use rule number 4. Clear, no? So what is given is, for us, x square plus is given over x square plus x plus 1 whole square. So these things now, how do you represent it? Ax plus b over first term x square plus x plus 1, correct? Then we have one more repetition, right? So we have to use cx plus d over x square plus x plus 1 whole square. So LCM would be x square plus x plus 1 whole square. This is like higher one, right? So to make it denominators are equal, what we can do is like we can multiply x square plus x plus 1 both numerator denominator for this only factor, right? Then how the equation would be now? X square plus 1 equal to ax plus b times x square plus x plus 1 plus this becomes like a cx plus d only. Correct, no? There is no doubt. So now how do I identify unknowns a, b, c and d? The first thing is, let's compare the coefficients, equating the coefficients. I'm using equating coefficients of x cube. Okay, ax into x square. This is only the x cube value. What is the left side value? Left side is 0. Correct, no? So if we can write it, the coefficient in the left side for x cube is 0, and the right side would be ax into x square, ax cube is here. So a equal to 0 is what is given. Next one, what you have to do, equating the coefficient of x square. Equating coefficients of x square. Let's try out. Left side, the coefficient is 1 x square, so you get 1 equal to the right side ax into x, right? Ax into x, ax square, right? This is a plus b into x square, right? This is one term, just b, right? And hence b equal to 1 because a is equal to 0. Clear? Next thing, what you will do, equating coefficients of x. Let's try out. Equating coefficients of x. Left hand side we don't have x term, so this would be 0. Okay, right hand side ax into 1, ax into 1 is nothing but a. Okay, now what about this one, b into x, this one more we can get it, so this is b plus, look at this one, this is c. Now a equal to 0, right, and b is equal to 1, then 0 equal to, this is 0 plus 1 plus c, so c equal to how much, minus 1. Correct? Now c equal to minus 1. Let's compare the d constants, compare the constants of both sides maybe. So equating constants, because all we require is like how to find out a d. Constants, like left hand side is 1, we have 1. Okay, right hand side you see constants, this is x term, so only b into 1, that is one constant we have here, plus probably this is a d, 1 equal to b plus d. Then we know b value 1, so what would be the d? 1 equal to 1 plus d. This means d equal to 0. So there is no d. So now we know a, b, c, d. So can you plug in these values back to your partial fractions? Okay, let me line them. Good. And then try to put a different color. So this equation now, x square plus 1 divided by x square plus x plus 1 whole square. This is given. So how do you represent? Using this ax plus b by x square plus x plus 1 plus cx plus d by x square plus x plus 1 whole square. This is how you have to decompose into partial fractions, right? Now we know that a, b, c, d, we have to plug in the values. A equal to 0, so ax term is 0, b value 1, so ax plus b becomes like a 1 over x square plus x plus 1, isn't it? Plus cx plus d. What is the c value here? C is equal to minus 1, so I have to put minus here. Let me put minus cx, so minus 1x. Maybe I can put plus here, put a minus x here, and then what about the d? D is 0, so minus x is only 1 over x square plus x plus 1 whole square. If you wanted to move this minus to here, still you can do that. Take minus here and then put a minus back here. right? So this would be your partial fractions. Are you clear? Summing of these two partial fractions is resultant into original given proper fraction. Any question? This is clear, right? You are able to understand the complete process, and then how do you identify which rule that you have to apply, and then find out a constant, plug in back those values into your generic partial fraction equation, right? That is your answer. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Logically, we reached the end of the session. We covered rule number 4 here. So far we covered rule number 1, 2, 3, 4, and then basic concepts are the prerequisites. Feel free to go back and revisit the previous sessions if you have any doubts, or post the query in the chat window so that we will respond you back. Alright, stay tuned to the next session. See you all again. Have a good day.